let's look at something called squaring. Now here's a window, and it's divided up into 4 panes. Now let's look at taking the area of this window to calculate the actual number of panes. Let's say it's 2 feet high and it's 2 feet wide. Now how could we actually calculate the number of panes in this window here? Well, we could multiply 2 times 2, sort of the length times the height there. So we go 2 times 2 is 4. Now we can also express this as 2 squared to the exponent of 2, and we get 4. Now how about this window here? Again, we have a square window, and let's say we want to find the area in terms of panes in this window here. Let's say it's 3 feet high and it's 3 feet wide. Well, to find the actual area in terms of panes here, we would multiply the width there times the height, so 3 times 3 is 9. And then we could also represent it as 3 squared, or 3 to the power of 2, which again equals 9. Now here comes Hilbert. Hilbert has it's almost like a TV screen built into his stomach there, and it can display various things like this, 4 times 4. How could we represent that using an exponent? Well, we can say 4 squared, or 4 to the power of 2, and of course that is going to equal 16. Now I think that I see our friend Euclid coming along here, and he too has like a TV screen built into his stomach there, and I bet you that he's going to show us a problem. So there's the screen on the side of him, and let's see what kind of a problem he gives us. 0.5 squared. Now this means 0.5 times 0.5. We could multiply 5 times 5, get 25, and since there's 2 decimal places represented, we move over 2 places to the left. We get 0.25. Now here we have 1.5 squared, again a decimal number, and so that means multiply 1.5 times 1.5. Let's do a little bit of review. Let's do it using regular math here. So we would multiply 5 times 15, that gives us 75, and then 1 times 15, move over 1 place, add the numbers together. Now there's 2 decimal places represented in the numbers that we multiplied together, so we have to move 2 places to the left, and we get 2.25. Now here we have a fraction that's squared, and what you're going to do is take the numerator, multiply it times itself, then take the denominator and multiply it times itself. We can't do any canceling, so we'll just do that multiply and get 9/16. Now suppose that we have a square and it's x on a side. How can that be represented in our notation? Well, we can say x squared, x to the power of 2. Now supposing that I give you the actual value of x, well, 8. We'll substitute that in. So we want to square 8, and so that means 8 times 8, which gives us 64. Thank you.